All right, we're on scene here. Now, I'm talking to my class, my DPH and S class. We have one H and 1, 2, 3, 4, 5, 6, 7 S's. Yeah. Do you know that the world average for scores in S chemistry, you know what it is?
3.
No. 4. It's low.
Huh?
4. It's really low, don't you think? Do you know what it is for H? If S is 4, what's H? I mean, I'll forgive you the fact that I told you to go home and learn all this stuff yourselves because it's not very intellectual and you could do reading. But anyway, I'll forgive you. So what is H? Anybody? It's 4.5. It's higher. Isn't that amazing? Yeah, but that's significant. 0.5 is significant if you're talking about 1 through 7, you know, and right? All right, what we're doing is we're talking a little bit about valence electrons. We got to get some things on the board here with valence electrons. And you girls have anything you want to say about valence electrons? Valence electrons are essentially, I'm just going to throw some things out at you. They're essentially the S and P electrons. Okay? They're the S and P electrons. So, for instance, this is what it looks like. And I had this on the board and I never said anything. This is S and this is P. S is lower energy than P. You see that? It's lower energy than P. S is lower energy. The S are more stable. That's a significant fact. Yes? So let's do sodium. When I put that electron in there, that's the valence electron. That's what it uses for bonding. Yes? This is what it uses for bonding. It's a valence electrons. The S and P electrons are the bonding electrons. So let's look at magnesium. It has, first of all, sodium has 1 electron. Here's magnesium next door. 2 electrons for bonding. So this is why, if you look at the periodic table, sodium is here, okay? Magnesium is here, aluminum is over here. This has 1 electron to give up. It's going to become +1. 1 electron. Magnesium has 2 electrons to give up. It's going to be +2. That whole column is going to be +2. Yes? Or 2 plus, whatever you want to say. But you get it? So when this gives up an electron, it has 11 protons. Why does it have 11 protons before and after it gives up an electron?
Because the protons decide the element and they don't change.
Yeah, the protons decide the element, and you're not changing the element. You're just taking electrons away. So it has 11 protons and 10 electrons, +1. 12 protons gives it up 10 electrons. So all of these elements here in the beginning, and what's next? Silicon, right? Right? They're going to give up, this is going to be +1, +2, +3, +4. They're all going to have the same, what? Valence shell, right? They're all going to have the same valence shell. You see that? These are all going to have the same valence shell. Now, what do you think? What's next to, what's silicon? What's 15? Phosphorus. Do you think phosphorus is going to give up 5 electrons? Isn't this phosphorus? He's going to give up 5, or do what? It's going to what? It's going to take on 3 electrons. And so it's going to end up with 18 electrons. What's the nearest noble gas to phosphorus?
Argon.
Argon. So remember, we don't say the O word in here. We don't say the word that cannot be used. It's a noble gas thing. If that takes on 3 electrons, as opposed to giving up 5 electrons, don't you think mathematically it's easier to take on 3? So it's going to be like phosphorus. Phosphorus is going to be like argon. So it's going to be -3, because it's going to have the 15 protons, and now it's going to have 18 electrons. Right? What's next to phosphorus?
Sulfur.
Sulfur, -2. Why? Because it's going to take on 2 electrons. Just like oxygen. Just like everything else in that column. Chalcogens, that's what you call them. Old term, very old term. Yes?
Can we say silicon -4?
You could say -4. Yeah, you can say -4 or +4. It's usually +4, usually. Carbon can be plus and -4. Carbon seems to do that a little bit. Hard to say, let me just say on record, hard to say +/4 because a lot of them do covalent bonding. It's not, they don't do transfer of electrons. So when you're talking about valence shells, you're really talking about, you know, some kind of accounting procedure with electrons more than reality. All right, so what's next to sulfur?
Chlorine.
Chlorine, -1. Yes? 17 protons and 18 electrons. Anybody? Yes?
What's argon then?
Argon doesn't have a valence state. Argon doesn't react. I'll tell you a story about argon, not today. I'm going to end, okay? Because we're leaving in about 2 minutes.
Gases don't react.
The noble gases don't react. Well, some of the heavier ones can get to reaction. And we'll talk about those later in the course, okay? And we're off.